Hello, welcome to PhyzQuest. So far we have discussed vector calculus problems that appear in the JEST and the CSIR NET exam. Now we will discuss the problems of vector calculus that appear in the GATE examination. So here we will cover the GATE examination ranging from 2001 to 2019 and which there will be many videos and in different parts. So we'll start with GATE 2001. So here the question is, if S is the closed surface enclosing a volume V and n cap is the unit normal vector to the surface and vector r is positive, then the value of the following integral, that is surface integral of vector r dot n cap ds, we need to calculate. 4 options are given and we need to choose the correct option. So let's get started. So as you can see, if you look at the question carefully, this question is actually based on the Gauss divergence theorem. So as per the Gauss divergence theorem, the surface integral of a vector is equal to the volume integral of the divergence of the vector. So the given integral is the surface integral of r dot n cap ds. So as per the Gauss divergence theorem, this is same as the volume integral of the divergence of the vector, that is volume integral of del dot r dv. So in order to find out the value of the integral, we have to find out the value of del dot r. So del dot r is equal to, del vector is I cap del by del x plus j cap del by del y plus k cap del by del z dot I cap x plus j cap y plus k cap z, which is equal to del by del x plus del by del y plus del by del z. All the three values have components have value 1. So this is 1 plus 1 plus 1, which is equal to 3. So if you put the value of del dot r in the integral, this will be 3 into volume integral of dv, which will give you the volume integral of dv will give you the entire volume, which is v, which is given in the question itself, which the final answer will be equal to 3v. Now if you look at the option, you can see that option D is matching with our result. So correct answer for this question is option D. So next problem is GATE 2001. The question is, consider a set of vectors 1 by root 2, 1, 1, 0, 1 by root 2, 0, 1, 1 and 1 by root 2, 1, 0, 1. These are the three vectors, set of vectors are given. Now there are 4 statements are given in the option and we need to choose which of the option is correct. There is one statement which is correct, so we need to choose that. So let's get started. So first of all, we are given a set of 3 vectors. They are 1 by root 2, 1, 1, 0, 1 by root 2, 0, 1, 1 and 1 by root 2, 1, 0, 1. Now if we write these vectors in vector form, that is 1 by root 2 I cap plus j cap, 1 by root 2 j cap plus k cap, 1 by root 2 I cap plus k cap. So these are in vector forms. Now the first, so here 4 statements are given and we need to choose the correct statement. So first statement is the 3 vectors are orthonormal. So first of all, what is orthonormal? Orthonormal is a combination of normalized plus orthogonal. These two conditions, when a vector is satisfied by a vector, the vector is said to be an orthonormal vector. So what is normalized? Normalized means when any vector is multiplied with itself, that means when the dot product of a vector is taken with itself, it produces the answer 1. So let's check that. Let's consider the first vector, that is 1 by root 2 I cap plus j cap dot the same. When we take the dot product of the same vectors, the first one, this will be equal to 1 by 2 I cap dot I cap plus j cap dot j cap. So this is, the bracketed term is 1 plus 1 is equal to 2 divided by 2, which is ultimately equal to 1. So normalized condition is satisfied by the first vector. Similarly, if we check the remaining 2 vectors, this will also satisfy the normalized condition. So first condition is satisfied. Now let's talk about the orthogonal condition. Now orthogonal condition means when any of the 3 vector is multiplied or dot product is taken with any other vector, then the answer it will produce is 0. So suppose let's check, consider the first and the second vector and take the dot product of both of them. So 1 by root 2 I cap plus j cap dot 1 by root 2 j cap plus k cap. This is equal to 1 by 2 I cap dot j cap plus I cap dot k cap plus j cap dot j cap plus j cap dot k cap. So out of the four terms, the first, second and the fourth term goes to 0. Only non-zero term will be this. This is equal to 1. So ultimately the answer for this dot product will be equal to half, which is not equal to 0. That means the vectors are not satisfying the orthogonal condition. So that means we can say that the three vectors are not orthonormal. So first statement is not correct. Now let's check the next statement. Next statement is three vectors are linearly independent. So first of all, we have to understand what is linearly dependent. So a set of vectors are linearly dependent when first condition is one of the vector can be written as a linear combination of the other vectors. This is one condition, or this is either or. Any of the condition should be satisfied. Either it should be the vector should be linear combination of other vectors, or second is one of the vector is a scalar multiple of the other vector. Either they are linear combination or the scalar multiple of the other. So now if you check the three vectors carefully, you can see that none of them can be written as a linear combination of the other two. Similarly, none of them are also a scalar multiple of the other. That means the three vectors are linearly independent. The second statement is three vectors are linearly independent, which is matching with what we have analyzed. So we can say that the correct statement here is option B. Now let's move to the next question. Third question is, if vector A is x ex cap, y ey cap and z ez cap, then del square A is equal to, we need to calculate. So let's get started. So the given vector is, vector A is equal to x ex cap plus y ey cap plus z ez cap, where ex cap, ey cap and ez cap are the unit vectors. So here we need to find out the value of del square A. Del square A is a Laplacian operator. So by definition, its formula is del square ax by del x square plus del square ay by del y square plus del square az by del z square. So ax, ay and az are the components of xyz components of the vector A. So here these are x, y and z. So if we put the value here in this place, this will be equal to del square x divided by del x square plus del square y divided by del y square plus del square z divided by del z square. Now for the first differentiation in each case, see all these involve double differentiation. First differentiation in each case will lead to the answer 1. However, when you do the second differentiation, each of the terms will lead to the value 0. So this will be 0 plus 0 plus 0. The total answer is of course 0. So see, this problem you can even answer without just even looking at it. You don't need to have to do any calculation. See, the trick here is, here the operator involved is the Laplacian operator, that is del square, that is a second order differential operator, and here the xyz components of the vector have the power 1, or you can say their order is 1. So whenever the power of the function to be differentiated is less than the order of the derivative, here the function differentiated has the power 1, the x is x to the power 1, y to the power 1, z to the power 1, and the differentiated and they are to be differentiated with the second order derivation, second order derivative. So that means here derivative has higher power. So in that case the answer will always be 0. So if you remember this trick, you can easily answer just by looking at it. So anyway, the final answer of this question is 0, which is option C. Now let's move ahead to the next problem. Next problem is from GATE 2002. The question is, which of the following vectors is orthogonal to the vector ai cap plus bj cap, where a and b, where both are not equal, are constant terms, and I cap and j cap are unit orthogonal vectors. So here we are given, here 4 options are given and we need to choose the correct option. So let's get started. So here we are given a vector ai cap plus bj cap, and from the given options we need to find out which of them is orthogonal to this vector. So the simplest way we can do it is to take the dot product of the given vector with all of the options. So, and which of them goes to 0 will give you the correct answer, because by orthogonal means whenever the given vector is multiplied with another vector, the dot product is taken of the two vectors, the answer should be 0. So what we will do is we will take the dot product of this given vector with each of the option, and whichever the answer goes to 0 will be the correct option. So let's do that. So when we take the dot product of vector ai cap plus bj cap with all the given 4 options, in that case, after doing the calculation, ultimately the first option gives the answer 0. Therefore, the vector given in option A is orthogonal to the given vector. That means correct answer in this case is option A.